All black holes were likely once giant stars. We have a fairly good understanding of where black holes come from, but not so much of why. Black holes form when very massive stars, having exhausted their nuclear fuel, collapse in on themselves under the influence of their own mass, compressing to the size of their gravitational radius. A black hole then forms in this location. The gravitational radius, also known as the Schwarzschild sphere, is unique to every object. Therefore, in principle, any object can be turned into a black hole if, while maintaining its mass, its volume is reduced to the Schwarzschild radius. For example, for Earth, this radius is approximately 0.887 centimeters, and for the Sun, 2.95 kilometers. However, neither our planet nor our Sun will ever turn into black holes, as they are not massive enough. Black holes are incredibly dense. Black holes are some of the most amazing and mysterious objects in the universe. Their main characteristic is their incredible density, mass compressed to a point where gravity is so strong that even light cannot escape. Just imagine, an object the mass of Earth would be only 9 millimeters in diameter, compressed to the size of a pea. Here are some examples of the heaviest black holes known to science. TON 618. One of the heaviest known black holes, its mass is estimated at 66 billion solar masses. The black hole of the quasar S50014+81 in the constellation Cepheus. Its mass is 40 billion solar masses. Black holes can shine brighter than stars. Matter trapped in the monstrous vortex around a black hole heats up to millions of degrees Celsius. Magnetic forces form two gigantic jets from the hot matter, which can extend for tens or even hundreds of thousands of light years. Such active black holes shine brighter than stars due to their accretion. Time stands still near them. Black holes are objects with such powerful gravity that they bend not only space but also time itself. The closer you are to a black hole, the stronger this effect. According to Einstein's general theory, massive objects such as planets, stars, and especially black holes bend space-time around them. Time appears to flow more slowly for an observer near such an object compared to someone far away. A black hole has an event horizon, a boundary beyond which nothing, not even light, can pass. For an outside observer, time practically stands still at the event horizon. If you watched someone fall into a black hole, you would seem to be moving ever more slowly toward the horizon and never actually crossing it. Why does this happen? The gravitational field of a black hole is so strong that it stretches time. The closer to the object, the greater the slowdown. At the event horizon itself, time freezes completely for an external observer. How fast can black holes spin? Black holes don't just sit still, they rotate. Like eddies in a cosmic ocean, when a star collapses to form a black hole, its angular momentum doesn't disappear. It transfers to the hole, causing it to spin. The more matter the black hole absorbs, the faster it spins. It's like figure skating. When a skater tightens their arms, they spin faster. So it is with black holes. Only on a cosmic scale, of course. The rotation speed of black holes is astounding. For example, the black hole GRS 1915+105 in our galaxy spins at about 1,150 revolutions per second, close to the theoretical limit. This is faster than any mechanical object created by humans. There are three types of black holes. These are stellar, supermassive, and relic black holes. The former are more or less self-explanatory. They formed after the death of giant stars. Supermassive black holes are black holes at the centers of galaxies. Scientists have several hypotheses about their formation. They could have grown from smaller ones, sucking in matter, or they could have emerged from a massive gas cloud. The first problem is that an incredible amount of matter is required to form a supermassive black hole. The second problem is that intermediate mass black holes have not yet been found. It's likely that there's another way black holes form that researchers are still unaware of. Relic black holes are hypothetical objects that are extremely small, even smaller than a proton. Naturally, it's impossible to find them, but they should have been abundant immediately after the Big Bang. Thanks for watching to the end. Subscribe. There will be more interesting things about space.